Actually, like, the test was exactly.
This test is not important. This is important.
No, but he got them to pass it, please.
For actual writing ones, I always after the rest they give us something that feels like completely different. You're like
For us?
Hello. I didn't mention it would have taken me like probably 2 hours. Why? Because I literally went on the side. Are you serious? Everyone's like sick.
nobody knows how to drive.
Oh my god.
Like, you know, you can't go on the street car up the sidewalk. How far do you go?
Okay, there's a space and like I can go through it, then it just moves a little up. And I'm honking and they don't move. So
Especially for right.
I went on the sidewalk when I went.
How are you? How's your weekend? How's your weekend? No? You're what? All day. Yeah, what do you do? Okay, I think we're gonna start.
Oh, you guys are waiting for me?
Yes, we're waiting for you.
Aww. Whatever floats your boat.
I don't know if you want to adjust that.
Yeah.
I don't think anyone can see anything.
Are you guys on Hebrew? Really?
Okay, let's see, it's 3:37, so that's pretty fast. We usually start closer to 4. I never start on
We
time.
always start half an hour late.
Oh, I just.
But that's because you like set it for 3:30 and not 3:30.
I think the reason why it's a little faster this time is because I have 6-period conferences here. Question 1. And basically we're just going to go through as many of these as you need to. If you need me to stop and slow down and explain, let me know immediately. Or maybe not immediately. Let me finish my sentence and then let me know. There is a camera. Right now the camera is always set to the screen. So it's screen capture. And there's also a small camera kind of recording my face just because I don't know why. It's just the way it is. So it kind of looks like that all the time. And I can make funny faces. So that's going to be off. Yeah, there's a microphone, so if you have a question, I'm sure hopefully it'll pick it up. If not, I'll ask you to repeat it, or I'll repeat it. So we're just going to go on with these. Question 1, variables to use to measure physical fitness. And I think what we're going to do is we're going to classify, just for a little extra, we'll just classify these variables as being quantitative or categorical, because that affects how we graph them or how we analyze our data. So I think the one that I suggested was time to run a mile. So it's variable and type of variable. So the one I had was, running time for a mile.
Oh, we have to say what type it is?
No, I'm just putting it out there. And time is quantitative, so this is a quantitative variable. Quantitative. Quantitative?
Quantitative.
Great. And do we have any other suggestions? BMI. BMI is a number?
Yeah.
So this is quantitative also. Yeah. You can push it closer to the screen. That might help. Or you could.
Repeat again the difference between quantitative and categorical data.
Hmm?
Can you repeat the difference between categorical and quantitative?
Yeah, better. Yeah, thank you.
Categorical, the responses you get from a categorical variable are going to be some kind of a classification. And quantitative is kind of a number. So if we said, I'm trying to think of a categorical variable here.
Weight. No, it's a number.
Weight would be a number. So.
Like obese, whether it's obese, underweight, overweight.
Okay.
So your fitness level basically, like numbers?
Yeah.
Fitness?
Like fitness classification.
Is it?
Body type.
That's not something for body type. Would that work?
Would that be categorical?
That would be categorical.
Yeah.
Just explain.
Yeah.
What would you use for that? Must be wrong.
That'd be categorical.
Did you drink your drink?
Huh?
Did you finish your drink?
That's definitely fine.
Sorry.
That'd be categorical because then you're just splitting it into this group of people and this group of people. Whereas quantitative, we're saying we've got this one person. Here's the number associated with that person.
So,
This is not necessary.
No, BMI is a number.
Which one?
Like asthma. That's a quantity.
Sure.
Yeah. Yeah, that would count as quantity.
yeah, but like,
For categorical.
Asthma?
Categorical.
That's yes or no, right?
Yeah, we'll go with that.
Yeah.
Yeah. That would be categorical as well.
Yeah, that's
so if for the people with BMI we're trying to figure out how many, or based on that overweight, underweight, regular, would that be categorical?
that would.
Overweight, underweight, obese, morbidly obese, those are categories.
Okay.
So that'd be a category.
But like if the actual number of the BMI, then it would be.
Yes. Okay. And then there's other ones, I think, standing heart rate. That'd be one.
Strength.
Number of sit-ups, sure.
Strength.
There's a lot of things you could do, exactly. So we're just gonna kind of not do a whole lot more.
Etc. Whatever that means.
Just write a couple of them, you're good.
That's how you measure center.
Okay, number 2. We put these in the calculator, and I guess this is a good time to start looking at the calculator. This is going to be the new calculator app.
I like the new 84s. They're all colored.
So we're going to take a look at stat edit, and we're going to put these numbers in here, and we're going to give them classifications. So, for example, 0 hurricanes, 1 hurricane, 2 hurricane, 3, 4, 5, 6, 7 hurricanes. And that kind of puts them all in there. What's kind of nice about this program is it gives you the numbers that I hit, the key punches.
Oh, that's cool.
On the board.
It's off?
Yeah, it's cut off.
Oh,
There we go.
so for L2 now, for L2 we can just go ahead and type in how many years out of those 56 did we have 0 hurricanes, and that's just 5. That's from reading the table, the histogram.
Is that just right? Are you just writing them down, or is that what we're doing in our calculator?
I'm doing it in the calculator right now.
So we can actually.
Yeah, you can do this in the calculator. How many times do we have 1 hurricane? I think we said that was 14 times.
Yeah.
Yes.
And then how many times did we have 2 hurricanes? Did we say 17?
I thought it was 7. I was in another class.
How many times do we have 3 hurricanes? 12. How many times do we have 4 hurricanes? 5 hurricanes? 6, 2, 1. Okay, and if we did that right, that should add up to 56. I'm going to assume it does. It doesn't matter a whole lot, actually. Okay, so from here, we should go to the home screen. So we're going to hit Alt. What is the Alt button? Or the second button? Second, quit. That gets us in the home screen. And in our home screen now, we're going to look at the 5-number summary. Okay, so stat, calculate, one var stats. Okay. This time it's different because we have a frequency list. Look, it's the new operating system. So happy.
Don't have to write down.
Yeah.
everything one by one.
Frequency list is in L2. So that's when we make that second list that tells us how many in each one. That's the frequency list. So we'll put that in L2. Now if I could figure out which one the second button is. That's frequency in L2. We'll calculate that. And we're going to scroll down until we get the 5-number summary. 5-number summary is 0, 1, 2, 3, 7. One more time? Yeah, you could use any list you want.
Do you suggest doing a calculator for all of these?
If it's possible.
Okay.
Let's go back to that. Oops. Let's just go back and take a look at that. I'm going to try and screenshot this. Okay, and let's put that in our notes. Oh, what is that? Undo. Take a screenshot. Screen 3. Capture. Copy. Paste.
Press 1. Anything you don't eat, I have dibs on.
You don't even have to whisper that.
What just happened? There we go. There's my screenshot. And then my 5-number summary.
How many numbers is this again?
Whenever I do my one bar stats, it didn't give me the option to do this. Just went straight to the sum.
Yeah.
So we give them the line.
Yeah, you need to update it. Do you want to... Someone want to update them? I just happen to have that one.
That may be the nerdiest thing I've ever seen in my entire life.
I
Having
know.
one of those just trusty in your back pocket.
I seriously did, and I'm a little bit embarrassed, but...
What did you don't have?
Huh?
It does have the wire.
I had a wire.
Oh, then you're embarrassed that you had a wire already just ready.
On him.
Yeah, I literally had it in my pocket.
Honestly,
Yeah,
I'd be surprised if you
Wait,
did
sorry,
it.
it was you go to send, you go to
Uh-huh.
link, and then you're sending which program.
Yep. You're sending OS. Second to last option.
Second, that link.
This is a backlight? What?
Okay, wait. He goes to receive and so cool.
Look how pretty this is.
Wait.
Yeah.
But when you checked one, you said it was okay.
I did?
Silver edition.
Oh, do I press continue?
Yeah.
Erases all random. What? Why is it?
You want some viewers? Go ahead.
Okay, it's gonna take a while, so you guys go on there move. Okay, that gives us this 5-number summary. Okay. We can also take a look at that. We can also take a look at the stat plot. So if you take a look at the stat plot, turn this one on. Scroll down to the box plot with outliers.
We should turn the second one on, right?
Our frequency list is in L2. Yeah, you should turn the second one off. We're using the box plot. Okay. And let's just graph this. We're going to zoom. We're going to zoom stat, which is number 9. And that gives us this lovely box plot. Which I will put here. Okay, it's a lovely box plot. And notice what it tells us. It tells us that right here we have ourselves an outlier. Work. Right there we have an outlier. Ah. Yeah. Yeah, there is a formula for it. It's significantly different, either significantly higher or significantly lower than the rest of the observations. There's a formula for actually computing it. I'm sure we'll get into it in a minute. Okay, now let's describe our center shape. Now the reason why I wanted to look at the box plot is the box plot looks skewed. So that's one part of our description. The first part is the shape. So let's get to a response. The shape of the distribution of hurricanes per year is a right skewed single peak. It'd be nice. Only if it's important. Single peak right skewed distribution. I'd like to look at how long is this whisker? Okay, do we have a long whisker on the right? Do we have a long whisker on the left? The other thing I like to look at is, what about the distance from the median to the maximum? Is that bigger than the distance between the median and the minimum?
Yeah.
Okay. So because both of those are true, the whisker is longer on the right side, and then the distance from the median to the maximum is also longer on the right side. I'm pretty safe in calling this right skewed.
Are we gonna get one for the 14 feet?
Possible, but there's very little we can do with that.
How can you see it with the box plot?
You wouldn't.
Okay.
You can't see that with a box plot.
So then how can you assure yourself that it's second peak?
Well, they gave us
Oh, Instagram. Okay.
they gave us the histogram.
No, I was only asking about the box plot because I remember when we were doing it, the box plot, and it looked like it was right skewed when it was actually left skewed. 'Cause
Yeah.
it was all the way to the right.
Right.
So,
Yeah. Box plots can be deceptive, so gotta be careful.
so does it depend on where the box is?
A little bit. Notice that our box is to the left, so that'd be a right skew distribution.
So if it's toward the right, it would be left side.
Yeah. Okay, so that's the shape. We can talk about the center. Because we have a right skew distribution, we're going to use the median. So the median number of hurricanes. Notice how I'm linking this to what the variable is. I'm not just saying the median is. The median number of hurricanes, I think it was 3, right? No, it was 2.
2.
Median number of hurricanes is 2. That takes care of center. So we've done shape, we've done center. We can look at spread. The IQR for number of hurricanes. Number is Well, that's 3 minus 1, right?
Did we just take out the points or is there something else?
No, you're done. It's 2. That center, shape, and spread, the last thing to do are the unusual features, which in this case means our high outlier. So there is a high outlier. Observation. And that high outlier is 7.
So, can we use the calculator to find outliers, or do you want us to show it?
You can use a calculator to show up to find outliers.
Do we just say we use the calculator to find outliers?
I'm assuming you're using the calculator. So that's a pretty good response. I'm a fan of that. Question 3. We have this hallux abductovalgus, a deformation of the big toe that is not common in youth and often requires surgery. We're taking a look at the angle of deformity in 38 consecutive individuals aged 21 who came into the medical center to correct their HAV. The angle is a measure of severity of the deformity. Here's our data. I imagine we should go ahead and put that in our calculator. So let's start this anew. So stat. Oh wait, I'm sorry. Let's go to the key press history and let's clean that up because we're starting a new one. So we're going to go stat, edit. Ooh, we still have stuff in there. Why don't we clear that instead? So we'll go to the home screen. Stat, clear list. L1 and L2. Just clear those two lists. Stat, edit. Now we have a clear list. We're just going to go ahead and put our numbers in there. So that's a lot of numbers. I'll pause for a moment while you guys do that. Or you guys can link it to each other too, I imagine. Oh my gosh, I'm using every USB port. What is wrong with me? Who uses all 4 of their USB ports?
I do.
I'm using all 4.
I use all of mine.
Yeah?
4 or 5, I use all of them. You're very adept with all this technology.
Thank you.
Yeah, it's like, do you know how to use a smartboard though?
Yeah.
Like there's not a single teacher I think who knows how to use it.
Cleary. Cleary.
Well, never had her.
Yeah. She's really good. She doesn't have an actual smartboard. She has another brand called Promethean. And she's good with it.
Miss you?
Miss You doesn't have a Promethean, does she?
I don't know. Unless she uses it for a little board. No, she does with a laptop.
Miss Cleary. Alright, so let's put this in here. Let's see if my 10 key skills are still valid. 32.
You know what the burrito is?
38, 32, and 21. What's with that 8? Why do I have an 8?
Bros, you gonna finish that? That? You gonna finish anything else that you haven't started?
No, I'm saving it for when I'm having it.
You're having your what? Have sip? Yeah? I'll come back. Or you can actually pour over this.
Where's 3222? Okay, I think I did this correct. I'm gonna hope I have all these numbers in my calculator correctly. Okay, so we're supposed to make a stem plot. Give a numerical description of the data. Okay, so you're working with a stem plot. You're gonna want to put these in order. Let's put them in order. We're going to the home screen, and then list. My bad. List. Ops, sort A, list 1. So we're just going to sort list 1. And let's take a look. Stat, edit. Let's see, 13, 14, 18. Yeah, you know, the 10s look good. The 20s, that's going to be a pretty long 20. We may want to split stems for the 20s. Do we have a lot of 30s? Let's check how many 30s we have. Give me a second. We don't have a whole lot of 30s.
Do we have to do the sectional one? Lower 10s, higher 10s.
We don't have a lot of 30s. We have no 40s and no 50s. So basically, your decision to split stems here will be, do you think the 20s is too long, or should we split the 20s? Probably should split the 20s.
Can you split one digit without the others?
No, you have to split them all.
Okay.
Do we have to say
And-
those?
Okay.
Pretty much
So we're going to split them all. Let's make this, we need to get to, what was the highest number, 70? 50. That means that there's someone out there with a big toe that's 50 degrees off.
That's so gross.
That is disgusting.
That's more than 45 degrees.
Whoa.
That's gross.
Like,
That's like, yeah, that's like your toes are crossing over.
So imagine that 5 degrees more.
what if it's the other way? Can you imagine the sock problem?
Imagine how much trouble he has putting on a shoe.
Probably can't wear sandals.
Okay, so let's see. Can I make a... Can I do this? So we have 1, 2, 2, 3, 4, 4, 5, 6, 6. You don't think it's a 50? Oh, my bad.
5 was on the second row of the split, right?
Yeah.
Yeah, I will.
You'll need the first 5.
We'll just keep that first 5 just for fun. All right, so we have 13, 14. Why do I have a split stem? We have a 13 and a 14. We have 16, 16, 17, 18, 18.
Will they always tell us what to use, what type of stamp plot, or do we have to figure it out?
You have to figure it out.
Unless they specify, right?
Yeah. We have 0, 0, 0, 3 zeros,
Here, just kind of flip them.
4 ones, 3 zeros.
1, 2, and 1, 3.
Ah. Oh, that's why. 3 zeros. How many ones?
4.
How many twos?
1.
1, 2. Any threes? 1, 3. How many fours? No fours? Okay, so 4 fives.
4 sixes and 3 eights.
Good. How many threes? How many zeros?
3 zeros.
How many ones?
1. 3 twos. 1 4.
Upper half of the
2
30s?
eights.
How many?
And then skip to 50.
51? 50. Okay. Okay, that's it. Yeah, that's my stem plot. Now I know, I hope everyone got the idea that if you just look at it sideways, like literally like that, if you literally look at it like that, it's a histogram.
Oh shit! That's really cool.
Especially yours. Yeah, that was like, I'm sure it's easier to make it look like this.
Yeah, come on. We should just do it that way.
Okay.
Because it's split stem plot, it would be different.
That's my stem plot. It's not very helpful for the other part of this problem. The other part of this problem is more helpful with the calculator. So let's go to the calculator again. Now that we have our numbers in L1, we'll go to the home screen. We're going to go ahead and do another 1var stat. Be careful that we just did this where the frequency list was L2, and that is not true anymore. We got to change that back to 1.
Or leave it blank.
Or leave it blank. Or leave it blank. Okay. No frequency list at all. Everything's in L1. Here's our 5 num sum. 13, 20. So our 5 number summary. Mm-hmm.
When it asks us to answer to write the description of the shape, center, and spread, would you like us to write the 5 number summary either way?
I think
Or is that just to help
that's
us?
really just to help you. Yeah, it's not. I don't need it for anything unless I ask for it. But this tells us right away what our median is. It tells us right away what our IQR is. And I just had a thought. We really should take a look at the shape of this data. So why don't we go ahead and look at a box plot? So let's make ourselves a box plot of L1. Okay. Now remember, you have to be careful because we just changed the frequency list to L2, so we want to delete that. Okay, now you want to push 1. And we're going to zoom 9.
Press Alt first. When I get hitting
Goes
Y.
Y, yeah, right?
Do alpha,
Oh.
Okay, take a look at this distribution. This looks like it's, well, one way you could look at it is the distance here from the median to the max is definitely bigger than the distance from the median to the min.
Yeah. So it's right.
So right skewed is definitely not unreasonable. But also, if you did not look at that outlier, that's pretty symmetric. If you take a look at this, that's pretty symmetric as well, right?
Yeah.
Okay. That outlier is going to drive the mean greater than the median. Okay. So that makes it look like it's right skewed a little bit more. So really, I'm gonna have two minds here. You could say symmetric with a high outlier. That's perfectly reasonable. You could also say right skewed. This one is not clear cut either way. Let's just use our 5-number summary. Okay. How is it asked? Yeah, 5-number summary would work.
We use the median and the IQR when there is a skew or an outlier.
Yes.
And then median standard deviation from zeros.
Yes.
And we're not doing that on this test, though, correct?
What do you mean?
Mean standard deviation.
Not as much as median and IQR. So the medians, what number? This is a median angle
Yeah.
is 25 degrees.
Angle of the toe, you should.
25 degrees with an IQR of 30 degrees.
That was 30 minus
30 minus 20 is 10, right?
Yeah.
All right, that's just me not being able to do math. Okay, sorry about that. So it has an IQR of 10 degrees. That takes care of center and spread. Shape-wise, this was a controversial one. I'm going to say shape the distribution of toe angles is right skewed with a high outlier, and the outlier is 50 degrees. Ouch. How do you even find shoes that fit you? Ooh. You can't cut off a big toe. I mean, you can, but yeah. Imagine that'd be a lot of blood.
You'd have to probably cut off the other one.
That's like machine girl amounts of blood.
I feel sorry for whoever has to go.
Okay, so do we?
Once I recall.
Okay.
Yeah, this group got messed up.
Okay, so that's our numerical description, and that's our discussion of center shape, and we've already also discussed outliers. So I think we've done everything here, right?
The center is median even if it doesn't go the way.
Center.
Median even if it's right skewed or skewed.
If it's symmetric, you would probably want to use mean more than you want to use a median.
So if we said that the shape is symmetric, should we write the median first?
Yeah. Well, if you look at the box plot, yeah. Notice how the distance between the median and then the maximum is pretty big, right? It's bigger than the distance between the median and the minimum. So based on that distance, you would say right skewed. Yeah.
I didn't say like it was
You could say symmetric with an outlier. I wouldn't mark you wrong, because you're right. It is symmetric with an outlier.
Would say that too, it would be right.
Yeah. Clearly, whoever this person is with 50-degree toe, that's the person you want to give an operation to. You didn't need a dot. You didn't need a plot to figure that out. Sophie? You should write in a paragraph form.
Can you go back to
No, because I need to write it.
I go back to your job here is really to communicate, and whatever you write you need to be able to communicate exactly what you mean. If I have to guess about it, then you didn't really do it. Does that make sense?
So how
Yeah.
much of whether or not it's skewed or not is due to subjectivity? Because like you said, it's controversial.
Yeah.
Is there a way of defining it, whether or not it's skewed or right skewed?
Yeah, there is.
There is.
And that
But we
would
don't
be
need to know that at the moment.
well, you will need to know that, but not for tomorrow. But if your mean is greater than your median, then that's a right skew.
Okay.
If the mean is less than the median, then that's a left skew.
Okay.
Okay.
But for now, if it looks like what we've been describing
Yeah.
is right skewed or left skewed, just say it.
Yeah.
Okay.
How'd that happen?
For stats, you can be in radian or degree. It doesn't matter.
Yeah. Stats you want to be in rate degree.
Degree. Okay.
Yeah. Yeah, for stats. Give me 1 second here. Clannad? Why would you do that to people?
What did you do?
Watch Clannad.
Just so that after we finish in Decade class, we watch Clannad. No! I want to see. You're heartless. You don't cry when it's Clannad. I know.
Okay, no. Okay.
You'll be the one we beat up later because you don't cry during Clannad.
Okay, that brings us to question 4, and we did a write-up on question 4 in period 1, so I just want to refer to that rather than going through the entire thing. So let's take a look at question 4. Are you ready?
Yes.
Question 4. We passed it? There it is. Okay. First one, range of the data. Range of the data is just maximum minus the minimum, so just 30. Next one, tell what each number of the 5 number summary is, and I've gone ahead and written a little bit about each one. The minimum is 16, that's just the least valued observation. Q1 is 20. That means that 25% of all observations are less than or equal to 20. Median is 22, so half of the observations are less than or equal to 22. Q3 is 30, therefore 75% of the observations are less than or equal to 30. The maximum is 46, so that's the highest valued observation.
Again, these are just definitions of what
Yeah.
is, right?
Yeah.
Is there a difference between range ones by the maximum spread goes by IQ 1 and IQ 3? Or is Q3
Question C, how many observations are strictly less than 22? So I kind of wanted to create a picture here. And the picture is this. We have the first 16 observations, then we have a median, and then we have the remaining 16 observations. So it's 16, median, 16. 16 and 16 is 32. The guy in the middle is the median, that's 33 observations. Okay. So it seems like the question is trying to bait you into saying that there are 16 observations that are strictly less than the median. Now that would be true as long as there's only one observation valued at 22. If you have repeats, then that's not true anymore. So, could be less than 16, but no more than 16 observations are less than 22. Maybe I should write that down.
Please.
No more than, oops. No more than 16 observations. We have 33 observations. The median, by definition, is the 17th observation of the 16, right? So that first 16, if they were all numbers that are not equal to 22 but less than 22, then that would be the maximum number of observations less than 22. Should we have repeats, then the number of observations that are less than 22 would be less than 16. Because let's say we had five 22s, then that cuts down. Now we only have 14 observations less than 22. Okay, yeah.
This is kind of a general question.
Sure.
So because number 4 isn't necessarily what, and it's because it's a definition or FRQ,
Mhm.
you wouldn't really give that to us.
No, it's not really. That's not really a test form question.
Okay. So a more likely test form question is number 2, in which you give us the data and then we
Yes.
have to describe it.
2, 5,
Not 3.
3. Yeah, 3. 2, 3, 5 are the ones that are most like an actual free response question.
Okay. Because it's so basically the test is just all about describing the data that you just looked at.
Yeah.
And doing whisker.
Chapter's called Describing Data.
Okay. Cool.
Oh, I'm sorry, Exploring Data.
Oh. Well, that's a little disappointing.
Sorry. Letter D. Is it possible that there is no observation equal to 22? The answer is no. Because you have an odd number of observations, the median is always one of the observations. Does that make sense? When you have an odd number of observations, the median is always one of your observations. There's always got to be one in the middle if you have an odd number. Yeah.
Say it one more time.
You always have to have an odd, if you have an odd number of observations, the median is always one of your observations.
Okay.
Yeah.
It would be even if you add like the 2 in the middle range, right?
Yes. Even number, it would be the average of the two. Good? Okay, what's next? That's D. Okay. Maybe I should write that down here too. The median is always one. No. If the data set. What's going on? Has an odd number. Okay.
How did you delete the whole word at a time?
Huh?
How did you delete the whole word at once?
Control backspace.
On Word.
On Word, yeah.
Really?
Yeah.
Type something ridiculous.
What would you do with those 47 minutes?
Go to the gym, bro.
Whoa, that's insane.
Are we gonna have our first break after we finish class 5?
Probably. E. How many observations strictly less than 20? So this is the same thing. We have 16 observations in the lower half of the data. So the median is the average of the 8th and the 9th observation. So it's possible that there is no observation equal to 20. Yeah. Since 20 is the average of the 8th and the 9th observation. So just kind of being aware on whether the lower half of the data is an odd number of observations or an even number of observations. G. Test for outliers. Are there any? Well, my IQR is 30 minus 20, or 10. So low outliers are anything less than Q1 minus 1.5 IQR. So anything less than 5 would be a low outlier. Now our minimum is 16, so it's not possible for there to be any low outliers. Okay? High outliers are any valued observation greater than 1.5 times IQR. If you crunch those numbers, you get 45. So if there are any observations greater than 45, that observation will be an outlier. Oh look, the maximum is 46. So that 46 would be an outlier. At least one, right? Because we don't know, there might be two 46s. Or there might be a 45 and a half. We have no way of knowing.
If it exactly 45, it wouldn't be an outlier, right?
I think it would not, it has to be strictly greater than 45.
Okay, so if it's equal to, then it's okay.
Yeah. John, did you have a question or?
Oh yeah, I was gonna say. So when it's a high outlier, if you get the high outliers of 45, it's not, if it's equal to 45, it won't be a high outlier.
Yeah, I believe it has to be strictly greater than 45. You'll never really be put in that position where you have to decide. And I. H was that modified box plot. And that's kind of on the thing already. Okay, just remember that you're not going to know where that whisker ends if you know if you have that outlier. We don't know where the high whisker ends. We don't have enough information to know that. So yeah, just end the whisker somewhere and you'll be fine. Okay?
But it can't be 46 because 46 is a high outlier.
Because 46 is a high outlier, right? So that high outlier or the whisker has to end sometime before 46.
Okay.
But the reason we don't know is because we only have the high numbers and enough.
Exactly. Not enough information.
But it would be accurate to put it at 45 because that's assuming that there could be a number that is 45, and that would be.
Well, no, I wouldn't
That's
put it
the
at
most
45.
possible.
I just end it somewhere.
Okay.
Somewhere. And lastly, approximately where is the mean? It's here. No. What is going on here?
That's a stem plot. Or it's a categorical plot or whatever.
That is.
Yeah, that's smart period. Why is that there? Sorry, yeah.
Oh yeah, the double leaf. All of them
Good match.
Oh, you can't have nice things.
Ah.
You can't have nice things.
Never be good enough.
Oh, I just made a huge mess here.
Just erase all the work.
How did that get there?
I don't know.
I think by now you know how to
Just
figure
the
out
cost.
your way of problem.
If you need all the numbers, you can just copy off the data from one bus page and you can just look for the most random.
Okay, that's good enough. Okay, and that's H. Approximately where is the mean? So because the distribution is slightly right skewed, you know that the mean should be greater than the median. And it's probably going to be less than Q3. So the mean should be estimated somewhere between 22 and 30. I don't know exactly where. It's not that important. As long as it's somewhere. Somewhere.
Are we gonna get a problem with that?
What problem?
It's just so long.
Okay. Mm-hmm.
If it was left skewed, what would it be?
It would be between, if left skewed would mean that the mean is between Q1 and median.
And if it was perfectly symmetrical?
It'd be approximately equal to the median.
It would be approximately median.
Yeah.
It was symmetrical.
So if it's right,
Okay, let's take a look at number 5. We want to make parallel box plots and back-to-back stem plots. Let's go with the box plots first. Let's make our box plots, and I think we got to put our numbers in the calculator, right?
yeah.
So let's stat, clear list. Let's clear list 1 and list 2.
Yeah. I erased it. Yeah, I just erased it. I had it before and I just erased it together.
I have it written down on paper, so you just want to.
I have it written down on paper.
Hey, you know what the best way to do this is to hire one person to read the numbers. And we all type.
Where do I stat?
Okay, who's our reader?
Okay, I'll do it. Fine.
Thank you, Robin.
Yeah, wait, is this for Western or Plain States?
Western.
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 Plain. That's
10.31, or am I rounding?
No, 10.31 is fine.
6.93, 6.93, 17.18, 20.05, 10.29, 6.33, 6.42, 6.14, 6.33.
Oh my gosh, what happened?
What number? What? Wait, what number are you on?
he's on number 1.
I'm on number 1.
No, what number? 10.65, 8.42.
Oh, no wonder I don't have print.
What happened?
It's my fault. It's totally me. Don't worry about me.
8.42, 1.87. That's 6 and 11.1.
Yeah, I think that's on. Keep going.
Okay. Donnie, now you're reading. Go for it. Go for it. What is it listening to? There's 13 for Western and 11 for you.
10.31. What am I reading to?
No, I think I got it.
That was supposed to be. Those are registrars.
What the heck?
That's 17.06.
10.29.
11.60.
Mm-hmm.
1.87.
When we draw the box plots on the test, do you want us to do the labeling scale for the x-axis? How exact would you like us to do? Can we just label the points that are on there?
Yes.
I would want the number line.
You would want the number?
I want the number line.
You told us that it means definitely got the number one, right?
Yep.
Yeah.
How exact?
Emphasize that third period.
Completely.
How exact?
Yeah, like is it okay if we go by tens? No.
Yeah, you can go. Well, I would probably go
It
by.
ranges 1 to 20. I don't
It-
suggest
yeah,
going
it-
by 10.
It
I'll
re-
go by like from 10 to 50 is okay if we go like 0 to 10, 20, 30, 40.
That's fine.
Oh, yeah. For this side, too.
Okay.
All right, let's turn these stat plots on.
How do you get there?
Second one.
Yeah, one to 5.
This color thing is so cool.
Yeah.
No, because it's super bright.
So then would you like us to label each thing or no?
Yes, I'm gonna actually go ahead and put this down. I'll make a copy of this. That doesn't make sense at all. I'm gonna go ahead and I'm going to draw it out so you can kind of see what it would look like. Okay, Rob?
So if we were drawing this on the test, we could put both box plots on the same.
Yeah, well, it tells you have to put parallel box plots. Okay, and let's see how that looks. Zoom 9. Well, that's awesome. Remember, the key here is trace. The trace button. It tells you that the minimum is 6.14. Let's go all the way to the maximum. I think it's 87.
87.
What the heck? All right, there's something wrong with my data.
Yeah, this is what we got.
In there or something?
This is what we did.
1030. Yeah. 1031, 693, 693, 1718, 2005, 1029, 6.33.
There's 13 and 1 and there's 11 and
6.33, 6.42, 614, 633, 10, 842, 1.87. All right, let's zoom it again. There we go. Okay, let's trace. Okay, we have 187 as the median, as the min. My maximum is 20. So it looks as though I can go by 2s or 5s. I'm gonna go by 5s. Okay. Okay, so let's make it. How did that happen?
Is there a reason why your box is on the axis?
I don't know.
Okay. Does that change? It doesn't change the data, right?
No, it doesn't change the data.
For every stem and leaf plot we do, we have to define what the leaves are, right?
Yep. This is true. Right, that looks pretty straight. So we're gonna go by 5s. 0. Let's make that 20. Let's make that 10. Let's make that 5. Make that 15. Okay, so my minimums for both of them is 1.87. So 187, 187. And I'm actually going to go ahead and just put them there because I don't trust how well I graph. All right, let's go to Q1s. Q1 here is 6.33, and okay, let's look for 6.33. That's about there. 6.33. The median is 6.93. So 6.93. 10.48. 10.48. 10.55. And what are our two outliers?
That's the 20 and the 17.
17, 18, and 20.05.
0.05.
Okay, that is plenty of accuracy. Okay. You don't need to get much more accurate than that.
That's perfect.
Okay? Is that reasonable?
Yes.
Okay, Q1 is also 187, right? What was the median? I'm sorry, 3.48? 9.48?
Would you have to write 1.87 twice? Because it's also the
Minimum.
minimum.
No, I don't think so. Did we say 9.48?
Yeah.
Okay, notice that I'm a little bit off here. What are you going to do? What's Q3? 1031. 1031. And max? 1706. Okay, that's good enough. Ooh, slight mistake. I really should make that little less than 1718, right?
Yeah.
Do the outliers have to be boxes?
They don't have to be boxes, but they need to be something.
They can be dots.
They can be dashed.
As long as there's something there.
That's better.
Good.
It's actually like slightly less.
Okay, back-to-back stem plots. This is going to be painful.
Is it really?
You just want to copy off some of the paper.
Back-to-back stem plots. Again, we're going to round the leaves to the nearest 10th place. So, oh. So we have the western states on the left. We'll have the plains states on the right. We'll get 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and we need to get to 20.
Wait,
Kidding.
you don't have, you never said, you never did that.
Why don't we do one?
Why don't we just do 1 to 20 straight instead of
Yeah, that's what we did.
Yeah,
It's a lot.
1 through 20 straight, not splitting.
That's what we did last time.
All right. So we're not going to split the stems.
We're not just splitting them.
Okay.
40 lines of paper.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20.
I swear this is on the previous one.
I am not saying next.
Okay, let's get to our calculator, and I think we're going to want to sort our values. Sort them out. So I'm going to go to Stat. No, I'm not going to go to Stat. I'm going to go to the home screen. And then I'm going to list ops, sort A, and I want to sort L1.
Hurry, you could just press stats and it's under the A.
Wait, is sort A the same thing in
Yeah.
list as it is in stat?
They sort different ways.
Listen here, buddy.
Someone's gonna get mayonnaise.
All right, now that we've done that, we're going to take a look at our lists. Oh, it is right there. And we're rounding to the nearest 10th place. So 1.9. So 1.9. 6.14, 6.33, 6.33, 6.93, 6.93. I forgot a
Forgot 2 floors.
where?
One floor. One floor.
Okay, and we have an 8-4.
It's not really long.
I know. Then our next one is 10-3, 10-3, 10-7. Let's scroll down. 17 and 20. 17.2 and 21. 17.2 and 20.1. That's great. Let's look at our plains states. We have 17.1. We have 11.6. We have 10.133. And then we have 9.5. And then 1.9, 1.9. There are 3 of them? There are 5 nines?
Yep.
1, 2, 3, 4. Yeah, we did. So we said the leaves.
Then it's rounded, or
Yeah.
for the benefit?
That's just for me to put there. So you know how I did this. So each leaf is worth 1/10. So you read that 1.9, 6.1, 6.3. And I think that's break time. Part B, compare the distributions. Okay? Part B, the plain states have a median that is greater than the western states. I think we looked at the 5-number summaries here for these, right?
And that's just bar scattering.
So yeah, let's put down the 5-number summaries for these. So the 5-number summary. What? Five-num sum for western states.
1.87, 6.33,
And I'm going to do this on the calculator. Calculate frequency list, leave it blank. Calculate. Here we go. There's my 5-number summary. I'm going to screenshot that for you. And we got the 5-number summary for plane states. So we'll do this again. Stat, calculate, one var stats. This time we're going to use L2. Yeah.
Where do you put it?
Wherever I want. No. I'm going to email it, and I'm also going to put it on Facebook. Yeah, it's right here. It's right here.
Of course. How much of your Twitter followers?
Where is it? Where'd I?
More than 60%. I'm gonna be
There.
surprised it's not easy.
Okay. We still need to compare, so we'll get on this in a second. That's always true. Okay, comparison then. The plain states have a median that's greater than the western states. You can look at that by comparing the two distributions. Both the distributions appear to be right skewed. The western states have an IQR smaller than the plain state, 4.15 versus 8.44. And the western states has 2 outliers while the plain states have no outliers. We look at the box plots for this, right?
Yeah.
Look at the box plots.
Go back to the box plot for a moment.
We don't have them.
Oh, why is the plane right skewed?
Yeah, why is it?
The plains states. Let's take a look. One thing you could look at with the plain states is if you take a look here, I don't remember which one this one is. I think this is the plain states. We have a mean notated with X bar of 7.1, and then we have a median of 9.4. So the mean is less than the median. That's a left skewed distribution. Now again, I don't remember which one I just did.
I think you did L1.
I said they were both right.
Yeah, that's what I was.
Let's see. That's L2. Let's do the one for L1. Whoa, what's that? One of our stats for L1. We have a mean of 9 and a median of 6. So that's right skewed for sure. Graphically, it's kind of hard to tell. Here are the two, oh nice, thanks for that. Here are the two box plots. It's kind of hard to tell the skew.
The top one is Western, right?
The top one's Western, yeah.
And we said that was right skewed or left skewed?
And apparently that's right, that should be right skewed.
Okay.
And then this one is the mean is less than the median, so it said it was right skewed. I'm not sure how I feel about that.
Wait, mean less than median and right skewed.
Mean less than median.
Plane should be left skewed.
Left skewed. Let's see.
If you do for the plane, the mean is 7.1 and the median is 9.8, 9.48. So it would be left. If that's how we're doing it.
That's how it should be. Left skewed.
Okay. Is that the answer?
Yeah, it's kind of bizarre to me.
No, the answer for number 5 is not
Unless you have a different copy.
Okay. Any other things from this? No?
Wait, you got number 5.
So both distributions.
They both appear right skewed. And that was just based on visually. They have a tail on the right side. They both have tails on the right side, so right skew looks better.
On the test, do we have to give reasoning why we say it's left to right skewed? Or
Yeah. And I'll be honest, these numbers are not the greatest for you to work with because there's some ambiguity in the shapes. You're not expected to be a master statistician yet. So working with these numbers is a little difficult. Yeah.
So, mean less than median is left skewed, and median less than mean is right skewed.
Yeah. Anything else? We're going to take a short break while I upload this to YouTube.
What video are we watching?
How long? Wait, we're watching a video? Episode 4 of Shit.
No! That'll take 25